Okay, welcome. So today we are going to look at the mole concept and we are going to start with mole. We are going to start with mole. So what is mole? A mole is the number of particles that are present in a given substance. Assuming now you have 1 gram of carbon dioxide. So the number of particles that are present in carbon dioxide, or assuming now you have 1 gram of, let's say 1 gram of soil, let's say loamy soil. So the number of particles that are present in that loamy soil is what described as a mole. So actually a mole is like actually it's an indices that trying to measure the number of particles. This number of particles, it can be an atoms, it can be an ions, it can be a molecules that are present in a given material or in a given substance. So the number of particles that are present in a given substance is what describes a mole. And this mole, it can be actually, or the particles that are present in the substance, it can be in the form of, it can be in the form of one, it can be in the form of ion. So the particles that are present in the given substances, as we said, a mole is the amount of the particles that are present in a given substance. So these particles can be in the form of ions, it can be in the form of molecules. So the particles can be an ions, or it can be a molecules, it can be an atoms. It can be an atoms. So therefore, we have an expression where we should know that one mole of any substance, one mole of any substance contains Avogadro's number. And Avogadro's number. So when you have one mole of a substance, so the one mole of any substance contains Avogadro's number, and this Avogadro's number is something as 6.02 times 10 raised to the power of 23. So this is what we call Avogadro's number. So ladies and gentlemen, we should know that actually we have an expression where we have a different formula in trying to express mole. And all of the formula that we can use in expressing mole, we have a formula which says mole is equal to the number of particles, and this number, the number of particles divided by the Avogadro's number, which is 6.02 times 10 raised to the power of 23. So this is also one of the formula that can be used to express mole, where mole is equal to the number of particles all over 6.02 times 10 raised to the power of 23. So then we also have a formula which says mole is equal to mass of the substance, divided by the molar mass, of the substance. So this is also a formula where you can also calculate a mole by knowing the mass of a substance with its molecular mass. Like for example, let's say we have 63 gram of carbon dioxide, 6 gram of carbon dioxide. So if we have 6 gram of carbon dioxide, of course from here we can calculate the number of particles that are present, or the number of atoms that are present in 6 gram of carbon dioxide. So we can calculate the number of atoms, that are present So you see, we have 6 grams of carbon dioxide, and we are now asked to calculate the number of atoms that are present in 6 grams of carbon dioxide. So I think it's simple. First, we need to calculate the molar mass of carbon dioxide, this CO2. So we know that CO2, carbon dioxide, we know that carbon has a mass of 12 grams, and we have oxygen with a mass of 16 grams. So from here we can calculate the molar mass of CO2. So how many carbon do we have here? We have 1 times the mass of carbon is 12. So we have 12 plus mass of oxygen. The mass of oxygen is 16, and how many oxygen do we have is 2. So we have 2 times the mass of oxygen, which is 16, and we put everything in brackets. So we have 1 times 12, we have 12, plus 2 times 16, we have 32. And after we add all these things, we are going to get 44. We are going to get 44 grams per mole. So this is actually the molar mass of carbon dioxide. So of course, as we said, we have the formula which says mass of a substance all over molar mass. So you can actually get mole from here. So you can now say mole is equal to, of course, the mass of carbon dioxide here is 6 grams divided by the molar mass of carbon dioxide, which is 44 grams per mole. So after getting this, then we can now press our calculator to get the mole of carbon dioxide. So how do we get the mole of carbon dioxide here? Is simple. So after we now see 6 divided by 44, we are now going to have our mole to be equals to 6 divided by this, and it is now going to give us 0.136. 0.136 mole. So this is actually the mole of CO2. So we now have the moles of carbon dioxide. So from here, since we have the moles of carbon dioxide, then we can now easily calculate the number of particles that are present in 6 grams of carbon dioxide. So how do we do that? Then we now use this formula. We take mole is equal to number of particles divided by 6.02 times 10 raised to the power of 23. So therefore we have the mole here already as 0.136 is equal to then the number of particles. That is what we are going to calculate. So we are now going to see the number of particles. So because here the number of particles that we want to determine from 6 grams of carbon dioxide is atom. So instead to say the number of particles, you can just say the number of atoms divided by 6.02 times 10 raised to the power of 23. So therefore we are now going to say the number of atoms. So we are now going to cross multiply. So this time this time this. So 1 times the number of atoms, we have number of atoms, then is equal to 0.136. We have it here, 0.136. Then we multiply it with 6.02 times 10 raised to the power of 23. So after we multiply this and this, then we see we are now going to have So this is actually how we are going to calculate the number of particles that are present in a given substance. So the substance here is carbon dioxide. So we have 6 grams of carbon dioxide, and we want to get the number of particles that are present in 6 grams of carbon dioxide, and that is why we follow all these steps. And I think, ladies and gentlemen, this is not something difficult. So a mole is the amount of a substance that contains Avogadro's number, and this Avogadro's number. So in every 1 mole of a substance, of any substance, then there is Avogadro's number, which is 6.02 times 10 raised to the power of 23. And then we have an expression where a mole can be the number of particles all over 6.02 times 10 raised to the power of 23. And here we also have a relationship between a mole and the mass of the substance. So the relationship is mole is equal to mass of a substance all over molar mass. And then we now said that, okay, now we want to see in 6 grams of carbon dioxide how many atoms, because when we said particles, it can be an ions, it can be a molecules, and it can be an atoms. So therefore now we want to see how many atoms are present in 6 grams of carbon dioxide. So to do that, then we now get the molar mass. First we get the molar mass of carbon dioxide. And how do we get the molar mass of carbon dioxide? By using the mass of the individual element that are present in carbon, which is CO2. So we have 1 mole, because we have only 1 carbon here. So we have 1 here times the molar mass of carbon is 12. So we have 1 times 12. Then we have oxygen, and the number of oxygen here is 2. So that's why we have 2 here. So we have 2 times 16. And 1 times 12, we have 12. And 2 times 16, we have 32. So we have a molar mass of 44 grams for carbon. So to get the mole, because we already have a mass of 6 grams, so we are now going to say 6 grams divided by 44. And that is how we get a mole is equal to 0.136. So after getting the mole, then we use the formula which says mole is equal to number of particles all over Avogadro's number. Then the mole is already 0.136 is equal to the number of atoms. So we change it as a number of atoms because from the questions here we want to get the number of atoms. So that is why instead of number of particles, so we now put the number of atoms divided by the Avogadro's number, which is 6.02 times 10 raised to the power of 23. And that is how we arrive actually after making all the cross multiplication. And then we now have 8.21 times 10 raised to the power of 22 atoms that are present in 6 grams of carbon dioxide. And I hope, ladies and gentlemen, this video will be important. So we are going to have another series of videos still on the mole concept. So this is actually a brief description of the mole concept, the definition of the mole, the 2 important formula that are used in calculating mole, and then also we have 1 simple example. So we are now going to see another example in the next video. So follow me, ladies and gentlemen, in the next video.